Hi guys, Mrs. Delisin here. Welcome to another lesson of Algebra 2. Today's lesson is exponential to log. So we are going to learn how to solve exponential equations that have log solutions. So in Exponentials 4.1, we studied how to solve basic exponential equations. They were basic in the sense that we could just use property of equality for exponential functions when both sides were exponential and that they have the same base. But what if they don't have the same base, and even if you write it into an exponential form, they still can't be written with the same base? Now, in those cases, we have to use an alternate strategy, and that strategy is to use common log and the power property of log. So let's take a look at the strategy that we are going to use. So we have first step. Okay, if you have a b to the power of x equals y and you want to solve for it, right? When you want to solve for the value of x, like what's that exponent? The first step is use common log on both sides of the equation. So from b to the power of x, it became log of b to the power of x. And then from y, it became log of y. So technically, I just inserted log on both sides, right? Before every letter or every variable, whatever that is. Okay? And then sometimes it's a number, that's why. So you just insert a log before a number. Okay, but in this case, it's before a letter. And then I'm going to use step number 2. Use the property of log to move the exponent. Property of log says that the exponent there can be written in front of the log. So I can bring the x or whatever that exponent later in front of the x. And then I'm going to be solving for x log of b equals log with log of 9. And of course, both base in here are going to be 10 because it's a common log. We don't have to write that. And then our goal is to solve for x. So we are going to eliminate log of b and divide that on both sides. So you are going to end up with x equals log of y over log of b. Okay, I'm going to copy this at the bottom over here. Okay, and now I'm going to follow exactly the steps says. First, 6x equals 42. Since they don't have the same base, so I cannot use this strategy where I can just focus on the exponents. So in this case, I'm going to insert log on both sides. So just write exactly what it is, but instead of just the numbers, I'm putting log before them. And then second step, I'm going to use the power property of log, that I can just move the x or the exponent in front of the log. So I have the same thing in here. And then I'm going to divide log of 6. And there you go. I have x equals log 42 divided by log of 6. So I've already taught you how to solve log of 42 in your calculator in the previous video. So you can either say 42 log or sometimes you press 42 and then press log. Other calculators will let you press log and then 42. Okay, so log of 42, hopefully you will get, and please don't round it. Whatever you see in the calculator, write the whole entire thing. And then log of 6 or 6 log would be 77815,125. So if I divide both of them, I will get 860,33133. But then it did say in the instruction to round to or leave your answer accurate to 4 decimal places. So I am going to round this. There you go. So 2.0860 is our final answer. Not that bad, right? Moving on, number 2. Same step. So we are going to do log 3 to the power of x equals log of 14.5. And then the property, power property says I can move that. So this is log of 3 equals log of 14.5. Divide that on both sides. You are going to have x is equal to 161368002 over, this is the lesson that we have to have a calculator, yeah, because this is something we cannot do in our heads. So 1.16, if I divide these two numbers, hopefully you will get 2.434115002. And again, I have to round my final answer, so I don't really need to write that whole entire decimals. I can leave my answer as 2.4341. Okay, that's it. Moving on. What if there's other numbers before with the power of x? Like, ooh, take a look at this. I have 120 times 1.05 to the power of x minus 5 equals 35. And remember, like, the rule just says b to the power of y equals x, right? B to the power of y. Oh, hello, not b to the power of y. What am I doing? Oops, let's go back. Here, just to make sure that you are not confused. There you go. So we have b to the power of x equals y. Okay, so let's write that down. B to the power of x equals y. B to the power of x equals y. So we have to have this kind of equation where there's only one b, right? Letter b, the base, to the power of an exponent equals a single number. But it looks like we have so many destructions in here. So let's clean it up a little bit. So we are going to get rid of the negative 5. So we're going to clean it up, okay? So should I add 5 on both sides, right? So this is 20, 1.05. Let me put a parenthesis instead of, I don't really like that because it looks like it's a dot or like 20 point whatever. So 1.05 to the power of x, and I'm going to get rid of the negative 5, so I'm going to add that on both sides. So that will be 35 plus 5. So hopefully you are thinking of having a 40 on that side. Okay, and it still look like it's not clean, so I'm going to get rid of the 20. So let's divide that. 1.05 to the power of x equals 2. And now it looks like clean, right? We have b to the power of x equals y. So this is the part where we are going to solve. So log of 1.05 to the power of x equals log of 2. Power property says that you can move that. So this is x log of 1.05 equals log of 2. And I can get rid of this. I can divide that over here. And then I'm gonna write it again, but you can do log of 2. Hopefully you'll get this a lot of numbers. Over 0.021189299. Okay, and this is equal to 2066991. Okay, around to 4 decimal places, 14.2067. Okay, there you go. Next. Okay, and again, we have to follow b to the power of x equals y. So we have to follow b to the power of x equals y. It looks like there's so many destructions in here. So we are going to get rid of the destructions one by one. Let's get rid of the first destruction, negative 11. So I'm going to add 11 on both sides. So 7 times 1.35x minus 2 equals 17 plus 11 is 28. and I can divide both by 7. That becomes 1.35x minus 2 equals 4. It looks like we no longer have a destruction. We have our b, we have our x, and then we have one value y. Okay, so let's insert log. 1.35x minus 2 equals another log of 4. And then I can bring that over. This would be 5x minus 2 log of 1.3 equals log of 4. Okay, what else? I can get rid of this. Get rid of that. 1.3. So this is 5x minus 2 equals, I am going to solve log of 4 divide by log of 1.3. Okay, hopefully you know how to do that already. So let me just write every single number. 11394335 So you'll get 5x minus 2 equals 5.283853603. Okay, what are you going to do now? So I'm not going to write, because like in my calculator, take a look, hold on. 38533603. In my calculator, I am going to just have 5.283853603 right now, right? And I know that I'm going to add 2. So right away, I'm going to add 2 to these answers. And then after I get that, I'm going to divide that by 5. So hopefully, you will get an answer of 456770721. Again, how did I get this answer? I put this in my calculator, I added 2, and then I divided that by 5. So I'm going to round my answers to 4568, right? 4568. Okay, there you have it. That is how you will solve exponential to log when you cannot write it as the same base anymore. Okay, thank you guys, and I hope that you'll be able to do your homework with no problems. If you have any questions, please let me know, and I will see you guys on the next video. Bye.